Hi, welcome to class Trigonometry, chapter 5, P1. What exactly is trigonometry? This is one of those best topic that I like to handle. Again, it is very versatile. It takes you to very other branches of mathematics. The word trigonometry comes from Greek roots, and we can talk about trigono. So it comes from Greek. We can divide it into trigono. So we have trigono. Trigono simply means triangle. So this means triangle. That is a sign of a triangle. And then trigono, tree. This means tray, T-H-R-E-E, T-H-R-E-E, tray. Then we have gono, and this means angle. Again, this is an angle. Then we have metron. Metron means to measure. Measure. So when we put all these words, trigono, triangle, tray, then we have gono, angle, metron, measure. So trigonometry literally means measurement of triangle. Interesting. Measurement of triangle. So ideally, in mathematics and in A level, when we talk about trigonometry, it is a branch of mathematics that study relationship between angles and side of triangles. Angles and side of triangles. But here in A level, basically we are going to look at knowledge that introduces more advanced concept beyond triangle calculations. So what we are going to look at is the properties of trigonometry functions. Some of the properties of the trigonometric functions are their graphs, their identities and applications in solving equations. We will also look at them in terms of modeling periodic behaviors and solving real-world problems. Right. Are you guys in class? I want, if you are in class, just wave. Just wave. Click on the wave button if you are in class. I want to be sure that you are following. So we are going to look at various concepts that involve modeling periodic behavior and solving real-world problems, looking at identities and solving some trigonometric equations, and also looking at properties of trigonometric functions. So that's what we are going to look at in this particular topic. But before we jump into it, come back to this image. Come back to this image. When you look at this image, what comes to your mind? Conceptual understanding. What do you know? What do you know? Let's look at the image. The Canada through robotic manipulator is a robotic system which has it has been operating on the International Space Station since 2001. It is primarily uses moving equipment and supporting astronauts while they are working on the exterior of the station. Again, the machinery is controlled by changing the angle of its joint, which requires repeated use of trigonometric functions. And that is why we say that mathematics is not just life, it is part of life. And we use it every day. So here you can see ideally mathematics involve what we do every day. So in this particular topic, we are going to sketch and use graph of the sine, cosine, and the tangent functions. And we have talked about tangents in circular measures topic number 4, where we say that a tangent is the line that touches the curve at one particular point. So let's proceed and look at some of the objectives that we must cover in this particular topic. Objectives of this topic, we are looking at how to sketch and use the graph of the sine, the graph of the cosine and tangent functions for angles of any size, and using their either degrees or radians. And that is why we first of all deal with how to convert degrees to radians and radians to degrees. And we did that in chapter 4. Use the exact values of the sine, cosine, and tangent of 30 degrees, 45 degrees, 60 degrees, and related angles. These angles are considered special angles, and we are going to use these special angles in order for us to find the exact value of the sine, cosine, and the tangent. Like when we look at cosine of 150 degrees, it will give you simply negative root 3 over 2. And you are going to see basically what you will be seeing more often is how to find maybe without using the calculator to find the value of a cos of a particular value, or maybe without using the calculator find the sine of a particular number. And I will guide you through and on how you can do that without the use of the calculator. Of course, if you are told not to use the calculator, you should not use the calculator, right? Use the notations like sine inverse of x. This is sine inverse of x. Of course, we talked about functions. Under functions, we have also looked at those inverse. So cos inverse of x, tan inverse of x, to denote the principal values of inverse trigonometric relations. Again, we are looking at how to use the identities. Sine theta divided by cos theta should be able to give you tan theta. And in some cases, you are supposed to prove that this is actually equal to each other. And again, sine squared theta plus cos squared theta is always equal to 1, even in your year 11 concept. So before you start conceptual understanding, you should be able to work on these simple operations. Again, this takes you back to what we did earlier in circular measures using the Pythagoras theorem. Here, use the trigonometric ratio and Pythagoras theorem for a right angle triangle. Yeah, so simply here you take 5 squared, 25 plus 7 squared, 49, give you 74. Take the square root of that so that you are able to find what is y. And we have talked about how you can convert degree to radians and radians to degrees. So this is very simple. If you want to convert to degree, divide by pi by 180. And if you want to go back to radians, simply take 100 divided by pi. Exact values of trigonometry functions. The unit circle can be used to define the trigonometric ratio, right? This unit circle can be used to talk about or define the trigonometric ratio. The angle theta is measured in an anti-clockwise direction. We have anti-clockwise direction, and then we have the clockwise direction. The anti-clockwise direction is also referred to as counterclockwise direction. Cos theta can be defined as the x-coordinate of P. This is the cos theta, the x-coordinate of P. Sin theta can be defined as the y-coordinate of P. This is the cos theta, sin theta, and tan theta is nothing but sine theta divided by cos theta. So the diagram can be used to write down the values of sine, of cos, and of tan for all these angles without the use of calculator. And that is why we are going to look at that. Note that the word cosine means the sine of the complement of that angle, or the sine of the complement of theta, where theta represents the angle. Sine co. It is sine cos-theta, eventually becoming what we know as cosine theta. So the cosine of angle POQ, the angle here POQ, the cosine of that angle is equal to the sine of the complementary angle, in this case OPQ, instead of OQP. So we are looking at this in terms of the theta, the angle to be sine into 90 minus that angle theta, or we simply take cos theta to be equal to sine of 90 minus theta. And we are going to see this now briefly in calculations. Without using the calculator, write down the values of those angles. And this is where you have to pay attention. You don't have to use your calculator. By inspection, how do I inspect? Using the unit circle. I will tell you that cos theta, this is cos 0 degrees. So I will tell you that cos 0 degrees is nothing but 1. You will ask me how. Now pay attention. We are using the unit circle. So the unit circle is a circle centered at the origin. It is a circle centered at the origin. Unit circle. Unit circle. Right. It is the circle centered at the origin. Right. It means that the coordinate is 0, 0, isn't it? The coordinate is 0, 0 with radius 1. It is a unit circle, so r is equal to 1. The coordinate of a point on the unit circle at an angle theta. So we measure this in counterclockwise direction from the positive x-axis, such that we are going to have cos theta, sin theta, cos theta, sin theta. So at 0 degrees, the point on the unit circle is going to be what? At 0 degrees, the point is going to be 1, 0. At 0 degrees. Because it is a unit circle. So at 0 degrees, the point is going to be 1, 0, right? So it is 1, 0, because this is cosine of theta. So it is 1, 0. So we know, conceptual understanding, that cosine is in this first quadrant. So it means the coordinate of this unit circle is 1 x-axis, 0 y-axis, right? So if you are asked cosine of 0, it is simply 1. Now look at the next. What about sine 90 degrees? Think about it. What is sine 90 degrees? Sine 90 degrees is the point on the unit circle, which is 0, 1 again. So sine 90 degrees is nothing but 1. Sine 90 degrees. If we check, it is going to be 0, 1. 0 on the x-axis, then 1 on the y-axis. 0, 1. The difference here is we have 1, 0, 0, 1, because this is sine. So 90 degrees. So this will give you 0 on the x, 1 on the y. So sine 90 is 1. Cosine of 180 is simply negative 1, right? Negative 1, because the point is now going to be negative 1, 0, right? This is 90, 180, so it is negative 1 here. Negative 1, 0. Cosine of 270 degrees. The cosine of 270 degrees, the point for 270 degrees by using the unit circle is going to be 0, negative 1, 270. So it is 0, because we have 0, negative 1. We take the 1 on the x-axis. 0. So cosine of 270 degrees is equal to 0. How about E, tan 0? Tan 0. Now we are going to use the identity we know. Tan theta is equal to sine theta. Divide that by cosine of theta. Right. So tan theta is what? Sine theta divided by cosine of theta. Such that when you look at what we have, what is sine theta? And what is cosine of theta? So you take sine of 0, because we have sine 0, so we can divide this by cos 0. So it is simply 0. So this tan 0, 0. Tan 90 degrees is going to be sine 90 degrees. Sine 90, divide that by cos 90. Cos 90. And what is sine 90 divided by cos 90? This will be 1 over 0. So tan 90 is undefined, because anything divided by 0 is undefined. So that is undefined. Or you simply write no solution in your answer. So this is very quick way you can find, without using your calculator, the values of this sine 0. I know most of you will still use your calculator. You can confirm your answers with your calculator, but make sure you solve it without using your calculator. So you can check the answers here and be sure they are correct. Example 2, find the exact values. So here you are supposed to find the exact values of the following questions given. So we have 120 degrees. Again, it will be important, if you have your unit circle, because you need to use the reference angle. You need to use the reference angle. We have x and y axis. We know this is cosine. This is first quadrant, second quadrant, third and then fourth quadrant, right? So if we are looking for exact value, a sine of 120 degrees, the reference angle 120 degrees lies where? It lies on the second quadrant. It lies on the second quadrant, right here. So what will be the reference angle? Sine 120. It is 120. It means this is more than 90 degrees. So we are going to use 180 degrees minus 120 degrees. This will give us 60 degrees. So 60 degrees is the reference angle, such that we are going to say that sine 120 degrees is equal to sine 60 degrees. And what is sine 60 degrees? Sine 60 degrees is root 3 over 2. So this is the answer to that question. B, cosine of 120 degrees. Our reference angle for cosine, cos lies here. So reference angle is going to be 60 again, because cosine, since it is 120, is going to be negative on the left hand side. So we are going to say that cosine of 120 degrees is nothing but negative cos 60 degrees. So this becomes negative a half. What is negative cos 60? It is negative a half. Sine 225. Sine 225. We have tan 120 first. This is C, tan 120. Tan 120 degrees is going to take us to reference angle 60 degrees, because tangent is negative in second quadrant. Tangent is negative in second quadrant. So what that implies is that it is going to be negative. If it is negative and the reference angle is 60, it is negative tan 60 degrees. And what is negative tan 60? You can use your calculator. It is negative root 3. Sine 225. 225 is a big number. That means it lies on the third quadrant. It lies on the third quadrant. So the reference angle is 225 minus 180. This will give us 45 degrees. So 45 degrees is the reference angle. Therefore, sine 225 is equal to negative sine 45 degrees. And what is negative sine 45 degrees? By your calculator, you should be able to get negative 1 root 2. Negative 1 divided by root 2 as the answer. Cosine of 225. Same reference angle will give us 45 like D, such that cosine is negative in the third quadrant. So it means that this cos 225 is negative cosine of 45 degrees. And if you plug that in your calculator, you get again it is negative 1 divided by root 2. And tan 300 is in the fourth quadrant. So if it is in the fourth quadrant, tangent is negative in the fourth quadrant. So we are going to say tan 300 degrees is equal to negative tan 60 degrees. And what is negative tan 60? Negative root 3. So this is negative root 3. And that's how you handle these questions without even checking the calculators, but use the unit circle in order for you to be able to solve that. You can look at these exercises. These are solutions to the first example that we did. Exercise 5.1, I have included the answers in the link below this video. And we can look at very quickly maybe question 1. Let's take 1 or 2 and try to look at it. You are supposed to find the cosine of 240. 240, when you talk about the quadrant, 240 is in the third quadrant and it is cosine, so it is negative, because remember cos is in the first quadrant. So if 240 is in third, then it is negative. So what happens is we have 240 degrees minus 180 degrees. This gives you 60 degrees. And if this implies that cosine of 240 degrees is equals to negative cosine of 60 degrees. And what is negative cosine of 60 degrees? This will give you negative a half. So the answer to A is simply negative a half, or negative 0.5. B, tan 135. Tan is in the second quadrant, and by 135 it is second and tangent is negative, so it becomes 180 minus 135. 180 minus 135 will gives you 45. So it is 45 degrees, such that it is negative. So what is negative tan 45? Negative tan 45 degrees is negative 1. So the answer here is negative 1. And you can do the same for sine 300. 300 is in the fourth quadrant. Sine, so it is negative, because remember it's supposed sine is in second. So the number is 300, it is negative. 360 minus 300. 360 degrees minus 300 gives us 60 degrees. So negative sine 60 is what? Negative root 3 over 2. So sine 300 is negative root 3 over 2. Solve the remaining questions and try to solve following the steps that I have indicated. We can look at a different kind of question, like question number 2, find the exact values of sine 3 pi over 4. You convert. When you convert 3 pi over 4, this is supposed to give us 135 degrees. And we have talked about how you can divide by pi over 180 or 180 over pi, such that pi cancels out and we multiply the remaining values. Number 3, without using a calculator, state whether each of these is positive or negative. Without using a calculator. So look at the first one. Sine 130 is in which quadrant? Sine 130 degrees. This is second quadrant, and sine is positive in that second quadrant. So this is positive. Second quadrant. Cos 130. Cosine is negative in second quadrant. sine 225. 225 it can be seen in third quadrant, 225, and sine will be negative in third quadrant. Cosine of 225. 225 can be found in third quadrant. Cosine is negative in 2 in this particular place. And you can do the same in B. Number 4, you express the following in terms of related acute angles. So look at all these questions, solve them, and try to check your understanding by the answers on the link of this video. So in the next video, we will look at the graphs of trigonometric functions and how we can work with this graph, especially in the specification of A and AS level Cambridge edition, IGCSE.